3D printing is full of promise for manufacturers, but is currently limited to single material structures. The materials and processes don't currently exist for multi-material printing across different sectors, and this prevents us from benefiting from the full potential of 3D printing for making complex multi-material products.
For the UK to achieve its net zero targets in the chemical industry, we need to shift towards sustainable ways of manufacturing fine chemicals. Using renewable materials such as biomass or novel green catalysts for chemical reactions has shown potential as a cleaner way of manufacturing. Unfortunately, the current state-of-the-art chemical reactors are not designed to support these newer green ways of production.
We're working on developing the next generation of 3D printing. 3D printing is currently mainly used to create clever shapes, but what we want to do is print the function too. And this means developing the ability to print complex devices such as multi-drug pills, 3D electronics, and even biological structures.
Our research is focused on developing a new chemical reactor using biocatalysts. This reactor has the potential to achieve continuous manufacturing of fine chemicals, meaning quicker production of high-purity chemicals and a reduction in waste generation and overall operating costs. Our goal is to then apply the reactor to utilize biomass to produce high-value materials for the fine chemical industry.
People should be aware that 3D printing is on the rise. It's not a done deal, and there's going to be many advancements to come. People need to be aware of its possibilities, as they're almost unlimited.
It would be fantastic if chemical companies and policymakers can work more closely together with researchers to speed up the use of innovative chemical technologies, so we can then achieve clean growth in the chemical sector.